Hi there and welcome. My name is Gauthier Choquet and I am a Microsoft Technical Trainer. In this module, we will explore the different options for deploying Azure SQL solution. We will dive in both Infrastructure as a Service, IaaS, and Platform as a Service, PaaS offerings, understanding their advantages and how they can be utilized to meet your organization needs. By the end of this module, you will be equipped with the knowledge to effectively deploy and manage SQL solution in Azure, leveraging the power of IaaS and PaaS solution with their own flexibility. So let's get started. The Azure SQL Platform offers a range of solutions for different business needs. Starting with SQL Server on Azure Virtual Machines, this option is ideal for organizations looking to lift and shift their existing workload while maintaining OS-level access. For those modernizing applications, Azure SQL Managed Instance provides a seamless transition with a compatibility for existing SQL Server features. Azure SQL Database is designed for modern cloud application offering scalability and performance. The distinction between Infrastructure as a Service and Platform as a Service highlights the flexibility of Azure SQL offerings. With Azure Arc, organizations can run Azure SQL on-premises and multi-cloud environment, eliminating the need for hardware and software management, which leads to operational efficiency and improved business agility. IaaS, or Infrastructure as a Service, offers benefits for deploying SQL Server. One of the primary advantages is the flexibility it provides. Organizations can scale the resource up or down based on demand, ensuring optimal performance without over-provisioning. Additionally, IaaS reduces the need for physical hardware, which can lead to cost savings and easier maintenance. Security is another critical aspect, as Azure provides some security and compliance certifications. Also, the ability to quickly deploy managed SQL Server instance in the cloud enhances the agility, allowing the teams to focus more on the development and innovation rather than infrastructure management. Overall, leveraging IaaS for SQL Server can lead to improved efficiencies and reduce operational overhead. Now, can we have both? Well, we can combine on-premise infrastructure with some of the resources in Azure. That's an option, right? This is possible. So think about a scenario with the organization Contoso transitioning to Azure. Hybrid scenarios could allow the organization Contoso to leverage their existing on-premises infrastructure while integrating it with Azure. This approach not only enhances operational resiliency, but also helps for managing the cost efficiently. When you go for a hybrid approach, keep in mind the potential performance impact as discussed during the previous module. The combination of on-premises and cloud services provides flexibility, enabling organizations to scale resources as needed while getting the most from the advanced capabilities of the cloud. I cannot talk about architecting data solution without talking about disaster recovery. Maintaining the availability and the integrity of our data is so important. It is interesting to see how we can leverage hybrid scenarios for our backup and disaster recovery. Related to our backup strategy, we could run our backups from our on-premise SQL Server directly into the Azure storage. And related to the disaster recovery strategy, we could have our Azure SQL solution to be used as a disaster recovery location. So then if there is an issue with the on-premises location, we keep our data running on Azure. On Azure, when we deploy our SQL solution with the IaaS option, we'll then deploy it on a VM, and the VM will have disk. When we follow the best practices for SQL Server on Azure, we actually recommend using premium disk for increased IOPS and storage capacity for the data file. Properly configured, the premium SSD will have latencies in single-digit milliseconds. And then for mission-critical workload that record latency lower than that, you should consider to use the Ultra disk. Be mindful that the values that you see at the bottom of the table are maximum value. So now let's imagine that you're working for a Contoso organization that has an application which is highly transactional. So that means that he needs to have a high number of IOPS against the disk. Now, with the premium SSD, would I get that 20,000 IOPS? Yes, this is possible, but this is a maximum value. To get the 20,000 IOPS, I need to have its data disk size at its maximum value, about 32 terabytes in this case. Why? Because the disks are managed solution, meaning that the higher tier we go, the more benefits we get. So the higher tier I go, the more IOPS and throughput I will get. Okay? This is a linear approach for our managed solution. Now we will learn PaaS option for deploying SQL Server in Azure in a whiteboard discussion. So let's go ahead.
All right, so now let's discuss our deployment options that we have available within the Azure portal through a discussion on the whiteboard. Okay, so in terms of deployment options, what do we have? Well, we have seen that we have the option of leveraging the IaaS approach, right, with the deployment of SQL Server on Azure VM, right? That's our option number one. Next, what we have, and this is what we're going to see now, we have the option of PaaS solution with an Azure SQL DB. And then another PaaS solution with a SQL managed instance or SQL MI. Okay, so let's see a little bit more of those here. So here, kind of a good recap between those different options for our deployment, right? So three main options. So let's see it in the portal. So what do we have? On the right, we can see SQL on the VM, managed instance in the middle, and a SQL database out there. Now, when let's say we want to provision those, yeah. So first of all, multiple options, right? We have the single database and the elastic pool. So let's discuss those options. So first we have the elastic pool, which is interesting. I mean, the single database first. Single database, so as the name mentions, single DB, it is for single databases. So what do we have? And we're going to do a couple of provisioning, not now, but in upcoming demos, we're going to do multiple provisioning of those. Yeah? So we're going to have an underlying logical server, which is actually a mix of compute and memory. Like that's what we have underlying. So a mix of compute and memory. Okay, and within that logical server, we will find our databases. Okay, be mindful that we cannot have queries across those databases. So those are isolated databases that we have. Okay, so that's with the single DB. Next, what we have seen on the portal is that we can have the use of the elastic pool, which is interesting. So similarly as the single DB, how does that work? Is that you still have that underlying logical server, right? Still the same, mix of compute and memory as well, logical server, yeah. And then the particularity of the elastic pool is that you still have multiple, or you can have multiple databases, right? And then when there's a higher need against a specific database, for example, okay, that you can provide some scaling option for those databases based on the pool of resource available. So if there's a higher need of usage for that specific database here, that database will be able to grow within limits that you define, right? So you allocate the storage and the compute to a group of databases, and then when the usage is not as high, then it will scale back to the size, to its original size here. Okay, so very interesting approach that we have here for those two options that we have with the Azure SQL database. Well, let's continue. Let's go back to the portal and let's start the deployment of a single database. Again, I'm not going to be deploying any database as part of this demo. This is just for me to talk about the different options that we have available when we provision those here, right? So multiple options that we have available here, right? So the database name and then the server. So potentially here, once again, we'll need to create that logical server as we mentioned here, right? We're gonna go through those as part of our creation and multiple upcoming demos. Okay, so for now, let's go back out there, right? So we go back to this one, multiple details of what we have access. So we can see it here. We have access to the single database. We talked about it, the elastic pool. Okay, but also you can see here, depending on what is needed, we have multiple options, right? With up to the hyperscale storage and so on here, right? So up to 100 terabytes. So that's interesting as well. Different options that we have here. All right. So when we go there, I'm gonna scroll down a little bit here. So configuration database for the compute and storage. So let's go there. Potentially here, we have two different options. We have the service tier and then the compute tier. Okay, so let's go ahead with the service tier at first, right? So service tier, I'm going to scroll down here the options. So we have a couple of options for the vCore approach, and then we have some options for the DTU approach. So let me go ahead on the whiteboard. As mentioned, we have the service tier, right, with two options. Gonna bring them down. We have gonna place a DTU on the left, okay, and then we have the other option with the vCore. Okay, I'm gonna explain the difference between those two, and then after I have a nice visualization for you, so that's going to be interesting as well. I'm going to include the visualization as part of the whiteboard here. Okay, so when we go on the DTU, so first DTU, what does that stand for? Database Transaction Unique, okay, unit. So we have the basic, standard, and premium. Basic for less demanding workload, okay, so when we start, that's actually the type of service tier we'll select for the demos here, for most of my demos. For our session, why? Small, right? The small data size here, nice. Now, after we have the standard, budget friendly, so we get some flexibility. See here, I have the DTU, so I can increase the number of DTUs. And as you can see, this is a managed solution. So the higher tier I go, the more benefits. So the more data size I would get. So pay attention to that number right there. So right now I'm at 250, but then when I increase the number of DTU, I can have potentially more data size as an option. Now, do I need it? Well, maybe not. So if I don't need it, then I can reduce the size of the data that I need. Okay. Next is the premium, highest availability and performance. So we even have that read scale out as an option here for more performing option. Okay, so let's recap what we have. So number one, basic. Small database. This is what I'm going to use as part of my demos, the standard and premium. Okay. Still a mix of compute memory for the service tier that we have as an option. Now the vCore provide a little bit more flexibility compared to the DTU. I'm going to explain this in a few here. So let's see what we have. And again, once we pick most of them actually, if we start with the basic DTU, can we later on scale to general purpose for the vCore? Well, yes, right? We're not stuck to one specific tier here based on the one that we selected originally. So we can scale up or down as needed. So now let's talk about those vCore approach. So first we have the general purpose, most budget friendly. Okay, we have the hyperscale, which is going to provide some data size up to 100 terabyte, okay, for more for larger data size that we may need, and then the business critical with the highest availability and performance on the back end. Okay, very interesting to understand how that works on the back end in order to understand how it can reach those amazing performance with the business critical. So let's go ahead. Let's place it here. So we have the general purpose. Then we have the hyperscale. Okay, and then the business critical. Remember that with the hyperscale can go up to 100. I mean, up to 100 terabyte. Right, so very interesting. Right, so let's recap those different options that we have out there. So 3 options for the vCore and 3 options for the DTUs. Now, what's the difference between those? Well, as mentioned, with the vCore, we have a little bit more flexibility compared to the DTU. Why? Because we have a little bit more control on, let's say we want a little bit more compute, then we can add a little bit more compute. If we want a little bit less storage or more storage, then we can also have that flexibility there. Flexibility that we don't have as much with the DTU here, right? So think about the DTU as one fixed price that you have available here. Actually, nice visualization I'm going to be using right now is this one. Let me bring it in front of us. Here you go. So you can see the difference between those two here. On the left, we have the DTU, a linear approach. So the higher tier we go, as we saw it, right? The more compute I get, the more storage I will get. Now, with the vCore model, it kind of reflects essentially what we could have on premises, right? Hey, we get that kind of like customization that may be needed. So it's a balance between the compute and the storage where we have a little bit more flexibility. Now, going back to our situation out here, when do we pick the general purpose? Well, if we follow recommendation, ideally, this is for workload up to 8 terabytes of storage, right? Ideally, based on that. So it's for light to moderate business need, light to moderate needs, right? All right, nice. While the hyperscale, as we mentioned, we can have auto scaling up to 100 terabyte for larger database here. So it's very interesting. So when you have that need for highly scalable storage and compute performance that will meet the largest need of SQL storage up to 100 terabyte, this is the service tier to pick, right? Very interesting, very large in terms of space needed for the memory. And the next we have the business critical, right? So this one is optimized for business critical application. Why? Because we have that high performance in mind, performance in mind, and then high availability. Right, so low latency response and high transaction rate. Okay, so very interesting option that we have here. Now, if we look at how that works on the back end, it actually leveraging the always on cluster as we would have with a SQL on-prem. Okay, now let's go on the left. As we mentioned, the DTU basic, database transaction unit, okay, for light transaction, okay, and small database size as we saw it. Okay, the standard would be for moderate transaction workload. It's also per minute transaction rate as well, and then the premium will go for higher transaction rate for more mission critical application that needs to have that highly transaction rate, right? So higher input output per second, higher IOPS. Okay, so always based on performance and actually what is needed. Now we can see there's multiple options that we have out there, and this is something that Azure does a great job with, is to give us some options, right? So multiple options based on your need. Now, can we go even a little bit deeper? Yes, right? So we talk about the service tier. Now, if we go back, can I go back? Yes. Oh, yeah, I went back out there. All right, so let's go back to where we were. I'm going to open this one. Scroll down. Compute and storage, configuration database. We just talked about the service tier, but we also have something very interesting here. We have the compute tier. Okay, so the compute tier, we actually have two. We have the provision and the serverless. Again, those are interesting as well. So provision, compute resources are pre-allocated, billed per hour based on the vehicle configure, right? So those are the compute tier. Let's bring it there. Compute tier, and then we have two. We have the first one, provision, and second one, serverless. Right? Let's bring it here. Provision we just talked about, right? So pre-build is there, it's available. Build, as mentioned, billing is per hour based on the vehicle configure. Now, if we use the compute power, well, great. If we do not use it, we're going to be built the same way. Like, think about now, your a scenario where you're beginning of life cycle of the application with a fairly new database, just on a dev or test environment. Do we need to run those environment 24/7, or do we need to run them over the weekend? Maybe, right? So if yes, provision will be a good compute tier for us. If not, what if we could leverage the serverless approach, which is interesting. Why? Because with the serverless, the compute resources are auto-scaled, billed per second based on the vehicle used. Okay, and that's one of the benefits that you can get as part of those compute tier here, is that potentially if there is no need of the database, you can actually enable the auto post delay. Okay, so actually not, I have the hyperscale being picked here, so there you go. So auto post delay, look at this, I have it enabled for 1 hour. So what does that mean? Let me bring us to the whiteboard. I'm gonna go down a little bit and paste the visualization. So if the database is not in use, well, potentially it can go on a pause state, right? So meaning that the database is still there, still existing, right? It's not being deleted or destroyed. It's just on a pause state. It's not active. So let's say we do not have any queries against the database. When we enable that auto pause delay with the serverless approach here, where potentially there's not going to be any costs related to the vCore, right? Consumption, right? There's going to be some costs related to the storage, related to the database and its storage being consumed and stored on our disk there. But the main cost for database, depending on its size, could be the compute power, right? So it is a good way to enable one of the benefits here through the computing with the serverless, especially for those databases on early development stage within the lifecycle for the application in order to optimize the cost, right? So can help us to lower the cost. I'm gonna place it here. Lower the cost in dev test. Now, consideration. Well, does that mean we cannot use it into production? Well, we have to be mindful, because what's going to happen when the database goes in a paused state? Well, we don't have access to the database, right? What if through the application there's some queries that's going to be, running against the database is going to wake up the database, but it's going to take few minutes in order to wake up, right? So the first few queries may be lost. Okay, so should you enable that serverless approach with the auto post delay in 1 hour, with the 1 hour delay within your production application, which is business critical? Well, maybe not, right? Now, if you tell me that you have an application that has to be available during business hours and it's it's an application for internal user only that has to be available from business hours only and is not necessarily to be needed during the weekend and all, well, potentially that's an option as well here. Okay, again, zooming out here based on what we've just seen, multiple options that we have, IaaS and PaaS. We're going to see a little bit more those benefits for the remaining actually of our session. We're going to focus more on those PaaS solution, look at some of the benefits that we can get through those PaaS solution, either from DTU or vCore, okay, and enabling targeting the right compute tier as well. Okay, and then with that being said, let's go back to our presentation.
High availability and disaster recovery are critical components of a platform as a service strategy. Regular backups are critical. With the PaaS solution, you can leverage the managed backup from Azure. In a couple of clicks, you can set up full backup running weekly, differential backup every 12 hours, and transactional backup every 5 to 10 minutes, depending on the activity and your requirement. This ensures that the data can be restored quickly and efficiently in case of a failure. The Active Geo replication enhances resilience with asynchronous replication database up to 4 secondary replicas, providing additional layers of data protection. Also, failover groups simplify the recovery process, allowing application to reconnect automatically after a failover without requiring any changes of connection string. This level of preparation is critical for maintaining business continuity and minimizing downtime. Deploying single Azure SQL database can be done in different ways, each depending on what you need based on the requirement. The portal offers a user-friendly interface for those who prefer a graphical approach. For automation and scripting, PowerShell or CLI commands provide powerful alternative, allowing for quick deployments with commands like new AZ SQL database. This command not only specifies the resource group and the server name, but allows you to set up the service objective and sample database. The Azure Resource Manager templates enable infrastructure as code, or IAC, which is ideal for repeatable deployments. Using the new AZ resource group deployment with a template URI, you will be able to streamline the process, ensuring consistency and efficiency. Understanding those options empowers you to choose the best deployment strategy for what you need. You can even go through its deployment with platforms like Azure DevOps or GitHub, or even third-party products like Terraform. Elastic pools are a deployment option in which you purchase Azure compute resources. It's a mix of CPU, memory, and storage that is being shared across multiple databases defined as a belonging within the same pool. An easy comparison to an on-premise SQL server is like an Elastic pool that has multiple user databases. By using Elastic pools, you can easily manage pool resources while at the same time potentially cost saving. Elastic pools also facilitate easy scalability with some limitations, so that if a single database within the pool needs resources due to unpredictable workload, the resources are going to be available. If the entire pool needs additional resources, a simple slider option within the Azure portal will facilitate scaling the Elastic pool up or down. What Azure does a great job is providing us with multiple options. In order to recommend some of the available options, we need to understand how that works on the back end. On the slide, we have the hyperscale availability model, which is divided into 4 different layers. The first one is the stateless compute layer. This layer runs the SQL Server executable processes and contains only transient and cached data, such as the no covering cache, TempDB model database, etc. On the attached SSD and planned cache, the buffer pools and column store pool in memory. It includes the primary compute replica and additionally several secondary compute replicas that can serve as a failover target. The second layer is the stateless storage layer. It's composed of page servers. This layer acts as the distributed storage engine for the SQL executable process running on the compute replica. Each page server contains only transient and cache data, such as covering the data cache on the attached SSD and data pages cached in memory. Each page server is paired with another in an active-active configuration to provide load balancing and redundancy and high availability. The third layer is the stateful transaction load storage layer. This layer is formed by the compute node running the log service process, the transaction load landing zone, and the transaction log long-term storage. Both of the landing zone and the long-term storage utilize Azure Storage, which ensure availability and redundancy for the transaction log, guaranteeing data durability for committed transactions. And the last layer is the stateful data storage layer. This layer contains the database file with the MDF file and the NDF file. They are stored in Azure Storage and they are updated by page servers. It leverages the data availability and redundancy features of Azure Storage, ensuring that every page in a data file is preserved even if processes in other layers of the hyperscale architecture crash or if compute nodes will fail. This option allows you to deploy a database up to 100 terabytes with scalability, performance, and more in a couple of clicks. Azure SQL Managed Instance is a powerful solution that bridges the gap between on-premises SQL Server and cloud-based services. It offers nearly a complete compatibility within existing SQL Server applications, making it an ideal choice for organizations looking to migrate to the cloud without extensive modification. This fully managed platform as a service, or PaaS solution, provides robust isolation and security features, ensuring that your data remain protected. The native virtual network implementation allows you for having a private IP addresses, enhancing security. Additionally, the tool available facilitates seamless migration process for SQL applications, enabling modernization while leveraging the benefits of a fully managed service. This combination of features places Azure SQL Managed Instance as a strategic asset for organizations that want to innovate and scale to the cloud. In this demo, we will set up the resources to deploy an Azure SQL database with a virtual network endpoint. They will validate connectivity with the SQL database using Azure Data Studio from the lab virtual machine. As a database administrator for AdventureWorks, you will configure the new SQL database, including virtual network endpoint, to enhance and simplify security. Azure Data Studio will be used to explore the use of a SQL Notebook for querying data and retaining the result.
All right, welcome back to this demo number 2, where we're actually going to deploy an Azure SQL database. And then once being deployed, we are going to connect to this Azure SQL database through the Azure Data Studio from this lab VM that I have in front of me. So let's get started and create a couple of resources here. So first, what I need to do is to connect to the Azure portal. So I'm leveraging a demo account here. So I'm going to use that username with the specific password that I have. All right, that gives us access to our, that gives us access to the Azure subscription that I'm going to be using as part of this demo out there. All right, so we can see that this is a brand new subscription. Okay, glad we're here. And then it's coming with no resources being deployed here. All right, so that's going to be interesting here. So when we have a look as part of this pre-built demo environment, there's no resources being deployed, but there is a resource group being deployed is there. All right, so interestingly, I'm paying attention to the location. So this resource group is being deployed in East US 2. So all of the resources that I will deploy as part of this demo will be placed on that specific location. Okay, a resource group, what is it? Well, it's kind of like a logical container that you have within your subscription for managing those resources, right? So all of the resources and component that I will deploy as part of the demo will be placed within that resource group as well. Okay, so that's going to be the intent for us. So first component that I want to deploy is the virtual network, because think about it proactively. We're going to be deploying a SQL database with the SQL server underneath it, and being deployed on a specific networking component, and then after we're going to connect to it. But how do we connect to it, right? That's going to be the question, a good question and a good goal for this demo. So first component I'm going to be deploying is the virtual network. Okay, so let's go ahead. Let's look for a virtual network right there. All right. Perfect. Gonna create that virtual network. So virtual network will come with its VNet and the subnet. Okay, we're gonna start from there, deploying the resource within the subscription and the resource group that we talked about. Okay. Next, I'm gonna give it a name. I'm gonna call it lab 02-VNet. Okay. Region, well, I need to change it. As mentioned, this is being deployed in East US 2. If US2, we have it there. Perfect. Okay, potentially there's security tab, IP addresses, and so on. I'm gonna go over those components in a few, so I can just go ahead and create it. All right, let's wait a few seconds here for its deployment. Okay, perfect. So the virtual network component has been deployed. So let's go see what we have. Okay, so as part of the deployment, what we have is the VNet itself. So we have 10.0.0.0/16, right? And then within this, we actually deployed a subnet. So within the VNet, we have a subnet that got provided, okay, with the name default, so default subnet that comes with a /24 and a 251 IPs available. Okay, so a /24 is actually 256 IPs, but why do we see 251? Well, the good reason is that Azure will reserve 5 IPs within each subnet. So even if a /24 is 256, 256 minus 5 is 251 IPs. Okay, so we have 251 IPs that we can leverage through that default subnet out there. Okay, when we look at the configuration of the subnet, something we're not going to do now, a bit later. So we have its old configuration. Potentially we can do some modification as well. But what we're going to look is at endpoint, right? So that's what we're going to leverage here in order to connect from the LabVM to that specific SQL database that we are about to create. Okay, so now let's go back to the root of our resource group to see what we have deployed so far. All right, so we have deployed the virtual network. Okay, as mentioned, we're going to deploy the SQL database. So let's go ahead and do it. SQL databases, going to create a new one. Right, so multiple component that we have to specify there. So subscription, I have only one, so I'm going to keep this one. Resource group, I have only one, so I'm going to keep the same one as well. So the resources will be deployed within this resource group out there, as mentioned. Now we need the name of our database and the name of our logical server where our database will be running from. Okay, so I'm actually going to be consistent with the name. I'm going to call it this with this name here, right, for the database name, but as well for the server name. Let's do it. So I'm going to create a new server name, right? So that's the underlying logical server where our database will be running from. Gonna give that name here. Location has to be the same of where we're gonna be integrating the with the VNet, right? So I cannot use the East US. I will have to use the East US too. All right, perfect. Now, authentication. Is that important for us to know when we want to connect? Well, yes, right? We want to connect to that specific SQL database, so authentication will be important for us. Okay, so I'm going to be leveraging the SQL authentication. So I'm going to give it a name. If you're doing this with me, pay attention to what you write because we're going to leverage this information in a few minutes in order to connect to the Azure SQL database. All right, and the passwords are matching, so we are good to proceed to the next step. All right, so let's continue. We're going to scroll up a little bit. Okay, so we were right there, creating the database name, database server. That's what we've just done. Do we want to use SQL Elastic Pool? Well, it is not the intent because we will do a demo with a single database, so there's no point of it, right? Remember the Elastic Pool, what it is that if we have, it's useful when we have multiple databases, and then if we have different usage of those databases over time, while because of that pool of resource through the SQL Elastic Pool, it can provide more resources available for some of the database when there's a higher consumption of it, right? So it's a pool of resource that can be used across multiple databases. Okay, this is not the intent of this demo, so I'm going to keep no workload environment. I'm going to keep the development here, right? Potentially we have two different workload here, which kind of build the profile for the database here. So I'm going to keep the development here. It's a dev database. And then on the compute and storage, I'm going to change this as well. So as we have seen, it has multiple options. Okay, so we talked about the vCore purchasing model and then the DTU purchasing model. So in this demo, I'm going to be using the basic one for less demanding workload. Let's say this is a brand new, this is a brand new database. I'm going to be using some sample data, which is a very small amount of data. So the basic tier works for me. But let's say that a couple of weeks from now, the application development is growing through its life cycle. Could we change it, or do we have to go through the creation of another SQL server? Well, no, right? So we can just scale in the future. So if we want to change on 2 weeks from now, for example, from basic to another tier, that's something that's possible as well with our Azure SQL database servers. Okay, so for our example, for our demo, I'm going to be using the basic as mentioned. Okay, so we have the basic information, the configuration, sorry, and as part of the backup storage redundancy, we'll keep the default geo-redundant backup storage. So this is the replication that will be applicable to the backup file the backup that we generate through this database server. Okay, so the backup file will be geo replicated, right? That meaning would be replicated against another region. Okay, all right. So let's continue. I'm gonna go on the networking tab. And you see the network connectivity, no access. Is that what we want? Well, no, we want to access it from somewhere. So I'm actually going to leverage the private endpoint, and this is something we're going to create right now. So private endpoint, what it is actually going to do a creation of a private IP address within the virtual networking component that we created earlier, and then it's going to represent my SQL database. So I'm going to be leveraging this private endpoint in order to connect to my SQL database that I'm about to create here. Okay, so in order to do this, we need to enable the private endpoint for connectivity method, and then we need to create it. So let's add it, add the private endpoint. So of course, pointing to that subscription, pointing to that resource group here. Location has to be this one. I cannot go around this one, right? So because, why is that? Because we created our networking component as part of EastUS2. So the endpoint, private endpoint will have to be within EastUS2 as well. That's why I'm deploying all of those resources within the same region, that for that specific reason. Okay, so let's give it a name. I'm going to call it the DP-300 slash SQL slash dash endpoint. That's why I cannot speak and type at the same time. I target sub resource. Good. We want to keep this one, right? We're pointing to a SQL server. So this is actually what we want. And now we need to point to the virtual networking component that we previously created. All right. So let's see. We have our VNet that we had created proactively, and the subnet with it's the name default, right? So that's what I'm expecting to see. Perfect. That's what we have out there. Now, what about the private DNS integration? Do we need it? Well, yes, right? So that's where we're going to be doing the integration with that virtual private IP is going to be created. So we have that private DNS zone. It's going to create as the specific link here. If we want, we could change it proactively as well. In my case, I'm going to keep the default value, but make sure you keep that value as yes here for integration with the private DNS zone. If not, it is not going to work as expected here. All right, perfect. So let's continue now that we have enabled the creation of the private endpoint. As we can see it here, right? It has not been created yet, but this is what we're about to create. So our deployment will take a few minutes, right? So that would be expected as part of this one here. All right, so we're going to keep the remaining configuration as part of the networking tab as default. On the security tab, I'm not going to change anything for this demo. Okay, potentially here's talking about the transparent data encryption key management. So, hey, do you want Azure to manage the keys? Well, yes, right? I'm not going to do anything specific here. Potentially we can have a little bit more control around those. Now on the next tab, additional settings, I am actually, as part of data source, I'm bringing the sample data, right? So as we have seen on previous demo, AdventureWorks LT database, that's the one I want to use or inject a simple data. Okay, very interesting on how you can create SQL databases here. You can create them without any data, right? That would be the first option that we have right now. You can create them with sample data. This is what we are about to do. I'm going to show you what type of data is being generated as part of it. Or you can just bring your own backup file. Okay, so if you have some backups coming from on-prem database, for example, and you want to create a new Azure SQL database by leveraging that backup file, well, this is an option. You just point to that specific backup file that you want to import here. All right, tags, I'm not going to be using any for this demo. Let's just go ahead, review and create. It's going to look for the validation, and then once validation is going to submit for deployment, and our deployment is going to take few minutes from now. Okay, so why? Because it's deploying multiple resources, right? Creating the underlying SQL database server is going to create the database itself. It's going to create the endpoint and so on here. All right, so let's wait a few minutes for this deployment. All right, so as we can see now, the deployment is completed. So let's go ahead and see the detail of that deployment. So a couple of resources that got deployed, right? So you can see it here. We have the logical server with the name of the database that got deployed. Okay, so a couple of information we could have a look here, but then let's just grab the server name, right? This is what we're going to be leveraging here to connect to our database. Now, when we look at the security component, because what we want to do is security component is that we want to connect to the database, right? So we want to connect to the database, and then we want to look at the monitoring. The as part of the security component here, what we have is what we gonna leverage here to configure the access, right? So as part of the access, we need to mention what we have, right? Because we want to connect. Do we want to disable public network access? Well, yes, we want to point it to specific network, which is pointing to what we've done earlier, right? So I want to, when I scroll down from that page, I want to allow Azure services and resources to access this server. Okay, so enable that checkbox, and then as well as selected network on the public access network. Okay, that's what we're going to be doing. Leveraging, if you do not have those settings, it is not going to work. Okay, now that we selected the networking component of it for the security component of the networking access, now let's go ahead and open the Azure Data Studio. All right, so I'm going to be connecting from my lab VM through that Azure Data Studio. All right, perfect. Yeah, first time I open it, close it. Probably it's going to ask me if I want to update it. If not, I'm just going to open a new connection. Right, new connection. This is where I'm pointing to that server name that I collected before, right? Next, authentication type. Do I want to keep a Windows authentication? Well, no, right? Because we set it up for SQL login. Okay, so we're still pointing to that Microsoft SQL server with the server name that we provided. Authentication type SQL login. So this is where you need to remember the admin username we selected before. So mine was this one. All right, so maybe let's do later. And then the password. Right, connect. Okay, so you can see here the new firewall rule. We need this client IP address to be added within the server. Okay, so we have two ways on how we can do it. We can either do it from here, where we could add the Azure account and add our IP address here, or we can do it directly. We actually saw the option when we were on that page. We have the option here to add the client IPv4 address. Okay, so I'm adding it, which is coming from here. Don't forget to save it. If you don't save it, it's not going to be working. All right, so we can see that we updated the firewall rules based on the IP address. It's going to be leveraged from that lab VM. Okay, so if I come back the previous screen, okay, all of the information is still there. Username and password is still there. Let's continue, connect. All right, perfect. And we can see we are now being connected to that SQL database server with the different, with the database that we created. All right, so now what I want us to do is to create a notebook for it. Okay, so you can click, notebook will be interesting to use if we want to, if we have multiple SQL statements that we need to run over time, right? So instead of running them all the time, well, maybe we can create a notebook for those. So this is what I'm going to be doing. Create a text cell. So first one I'm going to be creating is top 10 customers by order subtotal. I potentially can bold it if you want. Nice. The next, what I'm going to be doing is click on the drop down here next to the plus cell, but what I'm going to use now is the code cell. Okay, so this is what we're going to have here for the SQL statement. Okay, so that's the SQL statement here that's going to be leveraged. I'm not going to necessarily go through it in detail. That could be a SQL statement that we have, and we are not pointing to the right database. So, all right, let's see it. All right, let's do it from here, being at the right scope. So let's do it again. Text cell. Okay, we're going to bold it as we did before. All right, let's run it. Let's look at the output. All right, perfect. So we have a table output here. So let's say that's the SQL statement we want to run. And then let's say we actually want to run two of them. All right, so let's add a text cell. Let's say now that we want to run the top 10 order product. I'm going to bold it. Then I'm going to add the code cell and add the SQL statement. Can I run it? Yeah, we have to wait a few seconds for that one to be run. But the goal of this is that even though you have multiple statements here, so first of all, we are interacting with our database that we just created, but also what we can do is that we can save those notebooks. That's going to be the interesting piece as well. So as part of our demo, let's just create a new folder. So potentially I'm going to create a DP 3001 folder with that notebook within that folder. Okay, so what I could do, so even when I close everything, right, potentially I'm going to close all of the notebook. No, this one we don't save it. When I open file, I can point from that notebook and then reuse the notebook that got created with the previously ran SQL statement. Okay, so what we have done as part of this demo is that we not only created the SQL database. Let me show you all of the resources that we created. So we started to create the virtual network. Then after that, we created a SQL server with the SQL databases running from that server. We enabled the private endpoint as well in order for us to have access to that Azure SQL database through the tool of Azure Data Studio. Okay, so combine demo as part of this one, and hopefully we're going to see you for an upcoming session.
In this module, we explore the key aspects of Infrastructure as a Service, IaaS, and Platform as a Service, PaaS. We looked into how these cloud services can transform your business operation by providing scalable, flexible, and cost-effective solutions. By leveraging the SaaS application, you can manage your infrastructure with ease, while with the PaaS solution, allow you to focus on developing applications and deploying them without worrying about the underlying hardware and software. We also discussed the benefits of using IaaS and PaaS, such improved efficiency, enhanced security, and the ability to innovate faster. These solutions empower your organization to stay competitive in a rapidly evolving digital landscape. Thank you for joining us in this module. I hope you have now a better understanding on how IaaS and PaaS database can drive your business forward. Keep exploring these powerful cloud solutions to unlock new opportunities and achieve your goals.